David Bryan and Bill Young and I would like to introduce you to what's a new kind of tool. We've got 2 or 3 of them over there, and we call them handybots. And what they are kind of a portable digital power tool that'll do a whole lot of different kinds of jobs. I think the best way to think about them is just as a smart tool. What we'll try to do for those who are down in front, you can sort of see what Bill and David will show you, and then I'll flip through some broader shots of the tool. As we go along. Good. So we call it a handybot, and the way these things work is essentially with a touch of a button, it puts kind of an awesome cutting, drilling, carving, machining capability right into people's hands for doing specific jobs and tasks. It uses a high precision movement system for X, Y, and Z that moves a cutting tool around inside what's a pretty small form factor and basically creates a human extension tool on a job site or for doing a project. You can put the handybot down on a piece of wood or up against a piece of material, and it actually does the work through its bottom. You can sort of see the cutter sticking out here. It sort of machines things through its base. And many of you will recognize that at the core of this thing, it's basically a tiny little CNC machine. But it's a powerful kind of tool, and CNC, it takes advantage of that CNC capability. But the thing about CNC is it's not immediately associated with something you'd use on a job site, just because it's simple and or because it's complex and often hard to use. What is different about this handybot concept is that unlike a regular CNC tool, you bring the tool to the material. The other thing about it is that it's smart and simple because the tool is oriented to specific jobs or tasks. So let's say we want to cut out a specially sized hole for, say, a lighting fixture or something like that. We might take our cell phone, read a QR code off the instruction sheet that comes with the fixture, and then essentially run the app. The phone will load the project onto the handybot. The handybot will start blinking so you know it's ready. You line it up where you want the cut to be, push the little green button, and a few seconds later you'll have a perfectly cut hole. What I'll do is show you a video, if it runs here, of the handybot actually moving around and doing a little bit of that kind of work so you get the idea of what it does. These are close-ups underneath the base of the handybot. You can see it cutting through the material. Press the green button to start a cutting project. And the operator interacts with the tool in the sense of holding it steady and holding it down. It really is sort of a human extension. For light carving sorts of drilling and machining projects, the tool has enough weight, you just sit it down and let it go. For aggressive cutting, say cutting off the end of a 2x6, as is happening right here, then the operator holds the handle on the side to hold the tool in position while the cutting is going on. Here we used a little jig so that a series of 2x6 rafters could be cut with a precision cut rafter tail on the end of it, the sort of thing you might do on a job site, but you never get a nice clean cut like that on the job site. And you can see the tool working away here. It's able to cut to up to 4 inches in depth, so that means you can do fancy joints on 4x4s on a job site or for a project. It will illustrate here a couple precision cuts on the 2x4 that in theory you might do with other tools, but you'll see here that the precision of the cutting and the ability to get the thing exactly right is something that most of us couldn't do by hand, or even with a power circular saw by hand. The board underneath that's being machined right now was a 4x4 and essentially dadoed, that is grooved in a way that another 4x4 will fit precisely into it. It starts to give you an idea of all of the different kinds of jobs these tools can do and the sort of tools that they replace on the job site. Precision fit of that 4x4. The tool has a very relatively small, well, here it is in a fixture like the one over here, kind of illustrating the up against the wall application. This is a simple job, but you can imagine all sorts of fancy cuts that a tool like this HandyBot can do when it's been delegated to do something with an app oriented to some specific project or task. Here, its small working area is being extended by a jigging fixture that lets the tool move down a long board and carve out a banner. And in this case, it's cutting a mortise in a 4x4. You'll see how accurately it's able to do that. It exactly fits the 2x4, having just measured up before sticking it in there and running the app. Here, in this case, it's cutting a hole through a 2x6. You can imagine that this gives you an infinite size capability. You never run out of the right size hole cutter in your drill set here because you can cut a hole any different size. That's basically the way the tool works. What the idea of the thing is. Many of you will probably quickly scratch your head and come with ideas of applications on your own. And whether it's on job sites or for DIY projects, smart tools like HandyBots are going to be a powerful way to get things done with a sort of preciseness that most of us just aren't capable of doing by hand. We could lay out kind of dozens of possible jobs, tasks, and applications for a HandyBot ourselves. But we doubt that we as a company, or really any company for that matter, has the imagination, the creativity, or the resources to generate the sort of wide range of applications and ideas that will really fully enable the capabilities of these kinds of tools. So it's the emergent potential and the power of the community that makes us particularly excited about releasing this tool, this new kind of smart tool, as a open innovation project. It'll essentially be open hardware available for anyone to work on. And one of the interesting features of the construction of the tool, at least as we've designed it to begin with, is it's readily digitally fabbable. That is, you can cut it on a ShopBot or other CNC tool, both the plastic and the aluminum components. There are a few commodity items that we'll have to purchase, but otherwise the design and the accessorizing of the tool can be done almost immediately by anybody with digital fab equipment. And that includes the HandyBot itself. Might not be the most efficient way, but a HandyBot's perfectly capable of cutting all the parts for the next HandyBot. May not be self-replicating, but we like to think of it as self-morphing. Besides releasing it as an open innovation project and as an open source hardware, we're going to be creating an ecosystem for the app development, which will really be the critical part of enabling these tools. And we're hoping that by generating uses, applications, and some wide adoption of the tool, that there'll be enough of a demand that we'll be able to begin a distributed manufacturing process through small digital fab shops across the country. And in particular, we're thinking of the 100K Garage digital fab network that we've been involved in creating. So that's what a HandyBot is. The first batch of them we're going to make available through a crowdfunding project in June. We'll have them out here again today, as we did yesterday, so you can come up and have a closer look, try one out, figure out whether it's something you want to get involved in. We hope you'll follow us on the usual social sites, as well as getting involved in crowdfunding the HandyBot and perhaps being one of the early first adopters. Thanks a lot.